Hi friends, in this GATE CSE lecture series 19, let us discuss few questions on graph data structure. The question is, which of the following statements regarding breadth first search and depth first search on an undirected graph G is or true? Let us see the options one by one. The option A DFS tree of G is a shortest path tree of G. This option A is not true, it is false, because DFS will not ensure shortest path tree of given graph. The video lecture for DFS, the link is given in the description, so you can understand the concept of DFS. Option B, every non-tree edge of G with respect to a DFS tree is a forward or back edge. This option B is true. This you can understand from the previous lecture, that is types of edges. The lecture link is available in the description. So option B is true. Option C, if UV is a non-tree edge of G with respect to a BFS tree, then the distances from the source vertex S to U and V in the BFS tree are within plus or minus 1 of each other. I will explain this concept with a simple example. Let us consider this simple example, the BFS of this given graph. So we start with the root node 1, then breadthwise children's, that is the children of 1 is 2 and 3, then children of 2 is 4, 5, and children of 3 is 6, 7, and children of 4 is 8, 9. So this will become non-tree edge. And as you observe, the distances between source and destination is and plus or minus 1. That is what given in this concept. When we consider this example, the BFS of this tree is root node 1, then children of root node 1 is 2 and 3, and children of 2 is 4, 5, and children of 3 is 6, 7. This 10 also will be included now itself. But as you see, the distances, once it exceeds more than 1, it becomes a tree edge. So that means it is part of the BFS. So what happened now? So next 4, 5, 6, 7. After that 8, 9. So this will become a non-tree edge and this will become a non-tree edge. So as you see, the distances for non-tree edges are within plus or minus 1. So this concept is also true. Option D, both BFS and DFS can be used to find the connected components of G. So the answer is B, C, D are true. So you can listen to the BFS and DFS lectures. The link is given in the description, and also the types of edges, so that you can understand the answer, how it comes for this question. So the answer is B, C, D are true. Next question, let G be any undirected graph with positive edge weights and T be a minimum spanning tree of G. So there is a graph G and T is a minimum spanning tree of the given graph G. For any two vertices U and V, let D1 of U comma V and D2 of U comma V be the shortest distances between U and V in G and T respectively. Which one of the options is correct for all possible G, T, U and V? That means we have to identify the relationship between D1 and D2. Let us find the answer for this question by considering a simple graph G, and you find the minimum spanning tree of this graph G and call it as T. So how to find the minimum spanning tree of a graph G? We already discussed in a separate lecture. The link is also available in the description. So now you take any two vertices in G and compare with T. For example, you take A to D. So what is the shortest distance in G? 3. But here A to D it is 4. And you take another example A to B. So what is the shortest distance? 3 plus 1, 4. Is it or not? But here what is the distance? It comes 5. So what is the relationship is option B. That means D1 of U comma V is less than or equal to D2 of U comma V. That is the answer. Next question. The maximum value of x such that the edge between the nodes B and C is included in every minimum spanning tree of the given graph is dash. So we have to find the answer in integer value. Let us apply Kruskal's algorithm for finding minimum spanning tree of this graph. So as you know, in Kruskal's algorithm, we choose the edges in the ascending order of their weights. So 1, 3 is chosen. So if this is to be selected, this weight should be less than this 6, 7, 8. So the answer is x is equal to 5. So what is the answer? The maximum value for x is 5. So observe here the maximum value, because the value may be less than 5 also, but the question is asked for maximum value. So the maximum value is 5.